Hi, boys and girls, it's Miss Bissell. I just asked you to watch the visual learning video. It was a rather short video, but I like the explanation for what we're doing today, and I like the graphics. We are actually going to continue our chapter 15 today. We are going to be kind of putting together everything that we've been doing the last 2 weeks with topics 14 and 15. So we are actually going to be graphing and generating numerical patterns, and then we're going to be answering some questions. But our focus today is making sense of problems and keep working even if you get stuck. Just not that give it up, thinking that it's too hard. Having that I'm going to have to work and put forth the effort. That might mean looking at similar problems, but good mathematicians don't give up. They keep looking. They try to figure out if they're missing something, what they're missing. And like I said, a good way to solve that is to go back and look at similar problems. So our essential question is on page 606, and we're simply going to say, how can you make sense of a problem and persevere in solving it? So just a good basic essential question for what we're going to be doing today. However, we are going to be working with graphing and analyzing patterns. All right, so we did the visual learning video, dealt with the problem here. So you had a situation where the amount of corn, the acres of corn, actually increased to be more than the soybeans over the years. And you could see that when your two lines crossed on the graph. Now, when we do today's exercise, you're probably going to want two colored pencils sharp in different colors. Okay? I'm going to do one example with you, and then if you want to do a couple others, I will share the solutions. So the problem I want to work together is 607. So we have Mindy, who has already saved $20 and plans to save $8 each month. Georgette has no money saved yet, but plans to save $5 each month. Will the girls ever have the same amount saved? Explain. So the first thing we're going to do is fill out the chart after we write a rule. So when I go to the top, I see that Mindy's my first person. She's going to start at $20 because that's what she's already saved, and she's going to save $8 each month. So my rule for Mindy is going to be start at 20 and add 8. And we're going to add 8 to each prior term. All right. Our rule for Georgette is a little bit different. Georgette is going to start at 0, and we're going to be adding 5 each term. All right. So now we need to graph it. So let's focus on Mindy. This is obviously Mindy. We can put an M here, and Georgette. So Mindy is going to start at 20. We add 8. So at the end of the first month, she'll have $28. At the end of the second month, she'll have $36. The end of the third month, she'll have $44. So let's continue for the next 3 months. So we're just adding 8. That's our rule. So 44 plus 8 is 52. 52 plus 8 will give us 60. And 60 plus 8 will give us 68. Now, Georgette, we're going to start with 0 because she hasn't saved anything yet. At the end of the first month, she'll have 5. The end of the second month, $10. End of third month, 15. End of fourth month, 20. Let's fill out the fifth and sixth month. So the fifth month will be $25, and the sixth month will be $30. All right. And then the question is, on the same grid, this one right here, we're going to graph the ordered pairs in each table. So I need to start with my ordered pairs. So my very first ordered pair for Mindy, we're going to work with her, is going to be, let's see, 0 months, she has $20. So this right here, she started with, so this ordered pair the very first one, is going to be 0.20. Okay, so I want to get a color. I'm going to make Mindy green. So Mindy, from the origin, we don't go over any, but we go up 20. So her first point is here. All right, Mindy's second point, the second term, is going to be 128. Remember, the top line will be the x-axis value and the bottom line the y-axis. So if I wrote an ordered pair, it would be 128. So we're going to be, just a smidgen above or below, 30. The second month, will be 236. 236, so just a little bit over halfway. Third month, she's at 44. So 44 will be just a little below halfway. The fourth month, she will be at $52, so a little bit over 50. The fifth month, she's at $60. That one's right on the intersection of those two lines. And the sixth month, $68, just a smidgen below. All right, so if we connect her points with a straight edge, I did pretty good. We can see her pattern is moving in this direction. All right, let's work with Georgette. Different color. I'm going to use orange. Georgette, at the start, so at 0 months, she starts with no money. So Georgette's first point is plotted here. At the end of the first month, Georgette has $5, so halfway between 1 and 10, or between 0 and 10. At the second month, she's going to have $10. At the end of the third month, she will have saved 15, so halfway between 10 and 20. At the end of the fourth month, $20. At the end of the fifth month, $25. At the end of the sixth month, she will have saved 30. So we're going to connect those points with our straight edge. And you can very clearly see that unlike our example problem with the acres of soybeans and corn, Mindy, is always going to have more money. You can see that Georgette's never going to catch up with her. So Georgette is our orange, Mindy is the green. So that doesn't intersect. Actually, there just gets to be a bigger distance between their amount saved each month. So our question is, explain whether the girls will ever have the same amount of money saved. And the answer is no, they will never have the same amount. We just briefly talked about that. They will never have the same amount. And the reasoning for that is that the lines are getting further and further apart, so Georgette will never catch up. All right, we talked about this week. You need to pause the video, make sure that you have this problem filled out in your book on page 607 and that you understand it. The great thing about the video, you can rewind it and watch whatever part you need to watch again. All right, if you think you understand this concept and you have through the problem that was solved on the visual learning and through this guided practice problem, if you feel like you're ready to go work in your practice buddy, you can go ahead and work on that. If not, pause this video and why don't you look over the O'Brien's landscaping problem and then come back and we'll talk about it. All right, so the O'Brien landscape pays employees $15 plus $12 per lawn. Carter's landscaping pays $25 plus $10 per lawn. So we're going to figure out which company actually pays more. So if you were a landscaper, which company would you rather work for? So we're going to write a rule and complete each table. So let's talk about O'Brien's first. All right, O'Brien's. We're going to start at $15. And we're going to add 12. Whoops. Turning the lights back on. Sorry about that. We're going to add $12 per lawn. So you get $15 just for showing up for work. And then every lawn that you mow, you get $12. All right. It's a little different at Carter's. So if you go to work for Carter's, you're going to start at $25. Just walk in the door. You're going to get $25 for your work, but you're going to earn $10 per lawn. Okay. So that's our rule that we're going to use to generate the table. So we've got to put the data on the table. So using our rule, let's do O'Brien's on the top. We'll do O'Brien's in green in a minute. So O'Brien's, we're going to start at 15, so we're going to add 12. So after you're done with one lawn, if you add $12 to 15, you're going to have $27. After your second lawn, you're going to add another $12 and you'll have $39. The third lawn, you will add another $12 to the $39 and you get $51. If you mow a fourth lawn, you're going to add $12 to get a total of $63. If you mow 5 lawns, you're going to add 12. You'll have $75. And when and if you mow 6 lawns, you're going to get $87. All we're doing is adding $12 to each of the previous terms. And that's for O'Brien's. Carter's, we'll take care of in orange in a minute. But they start you out at $25 just for walking in the door, and they're going to give you $10. So after one lawn, you're going to have $35. After 2 lawns, you're going to have $45. After 3 lawns, $55. After 4 lawns, $65. After 5 lawns, $75. After 6 lawns, $85. All right. On the grid, that's our next section. So we're moving on this shared grid. We're going to graph the ordered pairs in each table. Now, I didn't write them above because I didn't really have room, and maybe that might have caused some confusion if you're still with me on the video. So let's write the ordered pairs. So for O'Brien's, let's start with 0, 15. Our next ordered pair would be 1, right here was the first one, and start is 0, right? 127. And we know that the top row would be our X value and the bottom row our Y value. And I'm kind of running out of room here on my desk. Excuse me a minute. All right, that might help. All right. So our third ordered pair would be 239. Then we have 351. 463, and again, the top number is the X value, which would be the number of lawns that you've mowed after your start, and the fifth one will be 575, and the last ordered pair, 687. All right, those are all the ordered pairs that we're going to use for O'Brien's in green. So 0 to 15, it's going to put us about right here. 1 to 27, about right there. 2 to 39. 3 up to 51. 4 up to 63. 5, 75. 6, 87. All right, I tried my best. Let's see, pretty straight. So we have a pretty straight line here showing your pattern. All right, now let's work with Carter's. So your first ordered pair would be the start, which would be your 0, 25. After one lawn, $35. After a second lawn, $45. After a third lawn, $55. After your fourth lawn, $65. After your fifth lawn, $75. And after 6 lawns, $85. All right, so let's go ahead now and plot these ordered pairs. Remember, we always start at the origin. We run on the X, jump on the Y. So that's why I go over 0 and up 25. All right, I'm going to go over 1 and up 35. I'm going to go over 2 and up 45. I'm going to go up 3, and that's going to take me up to 55. I'm going to go up 4 to 65. Up 5 to 75. Oh, at this point, right here, I'm going to make a note because it's hard to see, but at 75, you're making the same amount at 5 lawns. All right, at 6, we're going to go to 85. Okay. Now, I'm noticing something here, and it's hard to see it. If I went out 7 lawns, would be what, 95? 7 would be 95. Maybe you can see it if I do one more point. Something's happening very similar to what happened with the soybeans and the corn, our visual learning example. Do you see what happens? Carters will pay you more for 1 to 4 lawns. Okay, if you look, the orange line from 1 to 4 lawns, you're making more if you work for Carters. But the minute you get to 5 lawns, you know what? They pay the same amount. But 6 or more lawns, you're going to be better off if you work for O'Brien's, because then what you see is the green is the higher value. So if we are going to explain which company pays more, it's going to depend on how many lawns you're going to mow. So let's try to organize this in a sentence. So I'm going to say that Carter's pays more for 1 to 4 lawns. All right, and we see that by the orange being higher value from 1 to 4 on the number of lawns, right? Now, O'Brien's pays more for 6 or more lawns. So once we get to 6 lawns, you see how the green has the higher value. Now, if all you do is mow 5 lawns, it doesn't matter which company you work for, because 5 lawns is where you're making the same amount. So we're just going to make a little note that the pay is the same for 5 lawns. So it doesn't matter what company you work for. Okay. So again, take a minute, pause the video, see if you understand that. Like I said, this one crosses, so it's very much like what happened with the soybeans and the corn acres of those plants on our visual learning video. All right. If you want to look at it one more, if you want to pause your video, and if you want to go on the back page and work on this trackathon and see if you've really got it, if you want to work on that, pause your video, and I'm going to share my strategies and my answers with that one. So on the trackathon, if you chose to work it, all right, you've got Jordan running a trackathon to raise money for charity. Who will make a larger donation, Aunt Meg or Grandma Diane? So Aunt Meg was going to give you $8 just for participating, and then $2 per lap. Grandma Diane was going to give you $15 for participating, but only $1 per lap. So how can you make tables and graph to solve the problem? Well, you can make a table for each pledge, like here, and graph the ordered pairs in each table. Then I can use a graph to compare the donations. So here's my rules that I put with the tables that I generated. So I used the information up here to make my rules. So Aunt Meg, we're going to start at 8 and add 2. Grandma Diane, start at 15 and add 1. Here I completed up to 8 laps. So with the pattern completed, here's my information. Compare that to yours. And then I graphed the ordered pairs on a coordinate grid. So the ordered pairs are the corresponding terms. Remembering that start is really 0, right? When you start, you're at 0. All right, so 0, 8. Now, I just put M for Aunt Meg and a D for Grandma Diane, but you're going to see that what happens is they cross, and it looks like they're going to cross at 6 months, and it looks like they never pan out to be the same amount. So what happens is you can see from 0 to 6 months that Meg is actually, Aunt Meg is giving you less money, right? Grandma Diane's values are higher. But then these lines cross at 6 months. So not 6 months, I'm sorry, at 6 laps. So after 6 laps, then it switches. Grandma Diane is actually you're getting less money from her than you are from Aunt Meg. Okay? So my reasoning that I wrote out is Grandma Diane's donation will be greater if Jordan runs 0 to 6 laps. Let me show that to you. Aunt Meg's donation will be greater if he runs more than 7 laps. If he runs 7 laps, the donations will be the same. Oh, I missed that. You know why? I didn't graph very well. But look where I get that information. At 7, look what's happening. 7 laps, it is 22. You know what? I didn't do a very good job with my graphing. Whoops, sorry. And at 7, yeah, I kind of went off my line a little bit. See how my line went too far north? So I probably should have done a better job graphing, and I see it now. My line should have crossed right there. So yes, at 7 months, the donations would be the same. And I keep saying months. I'm sorry, guys. 7 laps. This is a run-a-thon. All right, so we are making sure that we are able to stick with it through a problem, that we can come up with a plan. Any problem like this, we're actually going to be creating a table, graphing the ordered pairs from the table, and then using the graph to compare the donations and make sense of what's going on in the problem. So you guys have your practice buddy for this lesson. Tomorrow, we all are going to be doing a review of topics 14 and 15 and getting ready for our big test on Monday. All right, I hope everybody has a great day, and I will see you soon.